In this example, we want to draw a Lewis-Dot structure, VSEPR structures, and determine if the molecule is polar. So we're going to look at ammonia and a silicon compound. So when we start with this, again, our first thing is to look at valence electrons, which for nitrogen is 5, plus 3 times 1, which gives us 8. So we put nitrogen in the center, put our 3 hydrogens. So we've used 2, 4, 6. Now we have 8 electrons. So we've used all of our valence electrons. We now have a Lewis-Dot structure. So our VSEPR structure takes into account the arrangement of these in 3D space. So as we have a steric number of 4, we can have a nitrogen where we have this arrangement. My preference is always I put the lone pair up top, and then we have the 3 hydrogen atoms. So from here, we can see that this molecule is slightly lopsided, and so the question asks, is it polar? So in this case, it is going to be polar because the electrons are going to draw the electron density from the nitrogen. So we can draw our polarity arrow that looks just like this. So in this case, we have a base geometry of tetrahedral. For our second example, we want to total up our valence electrons, which is 4 plus 3 times 1 plus 7, which gives us a total of 14. Silicon is our central atom. We'll connect our 4 items to it. We have 3 hydrogens and a chlorine. So we've now used 8 of our 14, 10, 12, 14. So we've used all of our electrons. Again, we have a base geometry with a steric number of 4. So we are going to have an atom that looks something like this. And so then we can put our compounds all the way around. Now the question becomes, is this molecule polar? And so we need to consider the electronegativities of any of these atoms. So silicon and chlorine are going to have a slightly polar bond because chlorine has a higher electronegativity. The silicon hydrogen bond will be nonpolar. Overall, this molecule will be polar, and the electron density will be drawn in this direction, and it's a tetrahedral molecule.